I do want to talk about Serverless Framework today. So Serverless Framework has been around for a bit. Really what we want to talk about is what is it, right? It's kind of the three major question or items here. What is it? What is the Serverless Framework? Why would I use it? And then how does it work? Pretty simple agenda. Before we get into the Serverless Framework specifically, I want to talk about serverless in a more abstract sense. Okay, Serverless Framework is a specific framework for building serverless apps that are somewhat cloud agnostic, and we'll get into those details. But the serverless idea is a more generic idea, right? An abstract idea of an on-demand approach to infrastructure. And this is kind of in contrast to the traditional infrastructure model we have, where we would provision dedicated or reserved infrastructure that, we say we want this OS, we need this much CPU, we want this much memory, we need this storage or this type of storage, right? And we're very specific about the things we need for the infrastructure. And that brings up all kinds of other concerns, right, around scaling and fault tolerance and things that you have to, quote, worry about, right? And the kind of the premise of the serverless model, which is a bit of a misnomer, because to run code, we're going to need a server, right? So serverless is really just saying we want to eliminate a lot of those traditional infrastructure concerns and move to a model that's more of an on-demand approach. This is often referred to, you'll see it in cloud provider documentation, as function as a service. The pricing is based on usage, so you don't pay for idle time. Like if I reserve a bunch of dedicated infrastructure, whether it's being used or not, I'm going to pay, right? I've said to AWS or Azure, hey, I need this type of machine and I need it to scale out to this size, right? And if nobody's using it, I'm still paying for it, right? The serverless model kind of flips that over and says, I'm only going to pay when it's being used, so I don't pay for idle time. And the main idea here, or the kind of the kicker, is I want to reduce the concern for all that infrastructure management, right? I don't need to provision, I don't need to manage, I don't need to patch, I don't need to worry about fault tolerance, I don't need to worry about scaling. All of the things that go along with that traditional infrastructure footprint are I won't say eliminated, but I'll say reduced greatly, right? That's the idea, is how can I make this easier? Zach, I forwarded Zach and Dave an email today we got from AWS on some infrastructure we had that says, hey, in August, this infrastructure is going away, so react, right? For us, not a problem. We got a couple databases out there we're going to have to go move. But if we think about if I'm an enterprise and I've got hundreds or thousands of these things, and AWS suddenly says, hey, this infrastructure you provision is going away, that creates a huge amount of technical debt, right? And a huge effort to overcome. And this idea is not ubiquitous. I can't use this for all types of resources, right? There are serverless databases and things. We're specifically talking about sort of the computing power today, but it's really the same ideas. How can I reduce that management footprint, that technical debt I accrue when I provision infrastructure, right? So that's the idea that we're going for or talking about. It's highly scalable by default. It's fault tolerant, right? When I, for instance, spin up a function on AWS Lambda, it's going to automatically be scalable infinitely. There are limits, right? But as much as I would need, it's going to be fault tolerant by default. I don't have a lot of sophisticated configuration I need to do to manage that kind of thing, right? So the idea is to simplify the application deployment process. Still have to write code, still have to manage the code, still have to manage all of my CI/CD, all of my DevOps up to that point, but the deployment side of it and the management side is greatly reduced. I'm going to click through these links just to kind of give you an idea of how the providers sort of advertise themselves, right? So we're going to look kind of at the three major cloud providers today. I'm really only going to deploy to two of them just as for demo purposes, but Lambda on AWS, Azure Functions, Google Cloud Functions, all are this function as a service kind of offering from the cloud providers. If you look at the AWS Lambda, right out of the bat, run code without thinking about servers or clusters, right? That's their tagline. That's what they're going for. How can I run code without managing infrastructure? Basically write some code, zip it up, send it up, and it's deployed, right? How can I get those things tied to events and trigger mechanisms to execute that code? save time by only paying for the compute time I'm using by the millisecond, right? Rather than that idle time. So that's kind of how AWS advertises it. Same kind of thing, go to Azure Functions, automated, flexible scaling for free to free you from infrastructure management, right? Integrated programming model to get those events and triggers in automatically, handling some of that sophistication. And then Google Cloud, much the same way. Run your code in the cloud with no servers or containers to manage, right? So this is the premise that we're talking about and what we're going to kind of dive into today. So far, so good? So that begs the question, well, if it's this easy, why wouldn't we always do this, right? Why wouldn't we deploy all of our infrastructure this way? Why wouldn't we just always write code, deploy it using serverless? And there are some things to think about in this world. The first is performance. And that brings up this idea of cold boot latency. So if you think about it, what they're advertising is, hey, you're going to have some infrastructure that's available to you, but not allocated until you need it. So it's really kind of a scale to zero model, right? If I was to spin up a bunch of EC2 or just standard virtual machines on a cloud provider, and I actually went in and shut them down, I don't pay for them while they're shut down, right? But the boot time on that is minutes, right? At least. There's still boot time in this world. It's fast, but it does come at a cost. So in that scenario where I'm scaled to zero, I have that first invocation or the first invocation after it's been scaled down, I'm going to pay for, right? It's going to be a little longer latency in that scenario. So if I've got real-time compute needs or I have really tight SLAs that I can't break, then this may not be a good model for this. This makes the implementation language choice important, right? Because not all languages and frameworks or approaches are created equal. For example, Node, Go, Python, Ruby, things like that are going to boot very quickly, right? When I execute some code, I don't have this large footprint or VM to load into memory, right? Class loaders, none of that's in play. Whereas like Java, C#, languages like that, they're going to be slower in general, okay? Package size matters, right? How much code do I have to load? That's going to affect the latency. And memory requirements. How much memory do I actually need to run the process, right? Those are all involved in that performance and that cold boot latency. The next one is then resource limits. In this world, all of the major providers, there's quotas or limits on what you can do with these functions as a service, right? So package size, meaning all my code and any libraries that are needed to run that code, right? I'm limited by that. I don't have all of the limits memorized, but I can tell you like Lambda is 50 meg zipped, or I think 250 meg unzipped. That's the maximum size of a package I can load, right? That seems like a lot until you start adding a bunch of libraries, and then it's not so much, right? So Alex Loggy did the presentation last month on the machine learning, our CFS predictor. I tried to put that in a Lambda, and that H2O Python machine learning package was like 200 meg by itself, right? So didn't work. So those types of things, are limiting factors. And then execution time. There's always a limit on how long any given function can run. Again, I know Lambda is 15 minutes, and they all have some window there that once I execute that thing, it has to be complete in some amount of time, right? So if I've got really long running transactions, not going to work. And also that leads into the next thing, may not be the best way to approach it, even if it does, right? These last two bullets, cost and vendor lock-in, aren't necessarily definite reasons not to do serverless, but things to think about when you're choosing which approach to use, whether I'm going to use a dedicated infrastructure or whether I'm going to use a serverless on-demand approach. Lambdas won't always be the cheapest, okay? If you think about execution, if I've got something that's constantly, I get thousands of requests per second, and there's little idle time, and I'm just constantly getting pounded, there will be a threshold at which reserving instances, dedicated instances on an AWS platform will ultimately be cheaper, because I'm paying per transaction in a serverless model. So you have to do the math, right? And that's not always easy to figure out. Now, that threshold is high, I think, in most cases, but there is a threshold that you could reach where cost is an issue, right? It's actually cheaper to go a different route. And then the vendor lock-in bullet, the configuration here is vendor specific. There's kind of a movement growing of this cloud agnostic idea, right? Where companies are saying, I want to write applications and I want to deploy them in such a way that I can say, well, I'm on AWS today, but I want to have this option to go to Azure, to go to GCP in a seamless fashion. It's a little bit of a pipe dream, I think, but it is possible to achieve some of that. From a code and function execution standpoint, the serverless framework is going to help us with that, and we'll look at some of that. Yeah, Dave.
Can you do a Terraform to achieve that? Like Terraform?
You can do it in a sense, but you still have to use a Terraform provider to say I'm going to, because all Terraform works on a provider mechanism where you say I want to provision infrastructure on AWS or on Azure. So Terraform would still be the vehicle, but I'd have to change my infrastructure code to make it work. It won't just seamlessly flip, right? And say there's no one-to-one mapping for everything, right? Because there's different things, there's different resources and services. Yeah, there'd have to be some sort of standard. Yeah, and there's so many services on these platforms, right? You think about like DynamoDB versus Cosmos, right? Very similar things between AWS and Azure, but completely different interface, different API, different libraries you need to use in your code to talk to them, right? They do the same thing, but you can't just say, well, I'm going to switch, right? And that's really that last bullet. Whatever my dependent function needs, if it's vendor specific, that code's not portable, right? If I'm going to move that from AWS to Azure, there may be libraries I have to change and APIs I have to change, and I have to change code to support that, right? So I may be able to move the function somewhat seamlessly using this framework we'll look at, but all of those dependent things, they put a fly in the ointment, I guess, is the way to say it. For example, databases, queues, DNS configuration, right? Am I using Route 53 or, using the Azure approach? Whatever I use specifically for the vendor, I'm somewhat locked into that if it's not a ubiquitous, easy to transition or migrate from. I don't know if you guys could hear that on the phone, but and I can't regurgitate all that, but essentially Zach was reiterating the point that vendor lock-in is a concern, right? If that's a concern of the client or our, who we're working with, then those are conversations that have to be had up front before you would choose an option like this, right? So let's look then at the serverless framework specifically. So just so I'm clear here, I'm talking about this framework, which is on serverless.com, okay? The interesting thing is when you Google, the name is so generic that when you Google serverless, it's hard to find just serverless framework stuff. So this is kind of your choice. Sometimes I'll put serverless framework in quotes, to kind of whittle it down, but it's an unfortunate name, I guess, in my opinion, that makes it hard to distinguish. Are we talking about a framework or are we talking about this more abstract idea of serverless? But I'm talking about this framework specifically here. What is it? The idea is and was and is, I guess is a better way to say it, is to ease this development and deployment in this world, okay? So that the traditional serverless model with any of the cloud providers is I would typically write my code. I have to write my code, which you'll see here in a minute, in a way that would conform to their model, okay? Specifically around event handling and triggers, right? How am I going to trigger this function? How am I going to get it to execute? What's going to cause that to happen? And then what does that event payload look like coming into it, okay? One of the ideas around the serverless framework is to ease that development and then the deployment. The deployment side is, typically I would write CloudFormation templates in AWS. I would use ARM templates in Azure. I would use the deployment manager in Google, and that's very specific syntax, infrastructure as code syntax to deploy onto their platform, okay? So if I'm going to do that movement, I have to have very specific configuration scripts to deploy on that platform is the easy way to say it. Serverless is flipping that over and saying, give me this sort of metadata YAML-based configuration, and I'll generate that infrastructure as code configuration for you. I'll generate the CloudFormation templates. I'll generate the ARM templates for you. So you don't have to write those specific templates. You give it a more generic configuration in YAML, and it will do that work for you. Right off of their website, serverlessframework.com, their tagline is develop, deploy, troubleshoot, and secure your serverless apps with radically less overhead and costs. That's what they're going for, okay? Radically is I guess, debatable, right? It is radically different, and it is easier. Whether it's radically less overhead and costs, I still think remains to be seen because of all the concerns and things that go along with any kind of application development. But in terms of just deploying serverless apps, it is far easier. It originally was created just for AWS, just to eliminate that CloudFormation creation of setup, right? We'll look at some CloudFormation templates here in a minute, but when you write a CloudFormation template, if you haven't seen them, it's basically saying, I want this infrastructure deployed onto AWS. I need these EC2 instances. I need this VPC. I need these security groups. I need these IAM roles. And it's a meta language to say, hey, AWS, go provision this for me. And Lambdas work the same way. I'm still provisioning things, Lambda functions and API gateways and trigger mechanisms in this world. But the idea was originally just AWS, and then they looked at it and said, well, wow, this is abstract enough. We can support AWS, we can support GCP, Kubernetes, several others, all right, in this same sort of way. So that's the idea. It manages the code, what code I want to deploy as a function. It also can manage all that sort of ancillary infrastructure, things like my databases, my queues, any kind of downstream dependencies that I have on that cloud provider for my function to actually run. It can manage some of that stuff too via its IAC mechanism. And it can support multiple languages, basically all the languages that are supported on the platform. So Node, Python, Java, Go, C#, Ruby, all of them that you see there. Good? Questions so far? Why would I use it? Again, the idea is simplification. I want to simplify this packaging and deployment process. The second bullet is why I kind of got turned on to this, because testing and debugging in a serverless world can be very cumbersome. Okay, if I actually want to set breakpoints in my IDE and step through functions that are actually Lambda based running on an on-demand server somewhere, that's a very difficult and cumbersome, can be a cumbersome operation. So this is going to make that easier. Is it foolproof, works in all cases, really easy in all cases? No, it's not. But it does simplify that and make it less cumbersome, and we'll look at some of that today. And it is really trying to abstract, as I said, those complexities away from writing CloudFormation templates or ARM templates, things that are very specific to the provider itself. It's well traveled. It has been used extensively. If you look at their client list, they got a lot of big companies using this, and there's tons of information. It's got a good head of steam behind it. And as a result, there's a ton of plugins. So it is plugin based. So if it doesn't do something we need it to do, there's either a plugin there, or you can write a plugin yourself to extend the framework. So how does it work? At a high level, it's abstracting both packaging and deployment. So it's going to allow me to, in an abstract way, build and package my application, zip it, essentially, and it's going to optimize that by default. And then I have a ton of ways I can optimize it myself, okay, further if I want to optimize the configuration. And then it's going to handle the deployment from an abstract standpoint. How am I going to get this package of code I just built out to the service provider, out to the cloud provider to actually run it and manage it? How can I set up those events and triggers so that it can actually be executed? So there's four kind of major concepts we'll look at: functions, events, resources, and service. Functions are exactly what we just talked about. That's my code. That's what I'm going to run. I'm going to write my code to do whatever operation or function that I need it to do. And we call those functions. Good name, right? Each function is an independent execution unit, okay? And it's what will be deployed, okay? A function is my deployable unit. You can think of it like a microservice. So any given function I write can have multiple, I was going to use the word endpoints, but I'm going to use the word event handlers, okay? Because it could be REST, it could be queues, it could be S3, it could be database triggers. There's a ton of ways to trigger this, and anytime that trigger happens, I want to execute this code, right? And that I can have multiple of those per deployment, or I can separate and say I only want one endpoint per deployment and separate it that way. But you can manage it. It manages that deployment mechanism. So it says it's a merely code deployed in the cloud. And so think of functions as just sort of small, discrete operations, right? I want to save something to a database. I want to process a file. I want to send an email, right? Typically, if you have long-running, high compute, high memory operations, this won't be the vehicle to go with, right? But for these smaller, discrete operations, one common use case and something I've used this a lot for is APIs behind my website, right? Very, very quick. If my website's not being used, I'm not incurring any cost for that, and those operations are quick, right? I just need some data. I need to save some information. I can process that through a function as a service. Next thing then is event. Functions, that code that we just talked about, are triggered by events, and they come from other cloud provider resources. Things like HTTP requests, file uploads into a simple storage like S3 or Blob. A schedule, like I want it to run every 5 minutes or once a day or whatever that schedule might be. Messages dropping on a queue. An alert, like alarm went off on my CloudWatch because I've got some sort of issue somewhere, right? I can react to that with an Azure or with a Lambda function. In this framework, when you configure an event on a function, the framework automatically does that wiring for you, creates the infrastructure needed. For instance, in the REST case, I would often put an API gateway in front of my Lambda functions. It'll create that for you, and it configures your function to listen to that. So that's kind of what the framework is doing around events, is simplifying that process. And then the next piece is resources. These are those other ancillary things, right? My databases, my queues, my email services, my simple object storage, anything that I need to, my function needs to interact with, I can manage that through the framework as well. This is probably, I think, the most overhyped part of this, because this is the least reusable piece of this, and you'll see why as we step through this. Because you really have to just fall back to the vendor-specific configuration, CloudFormation, ARM templates, or whatever to get that to work. I'm not sure it's possible, but they haven't abstracted every possible AWS Azure service into some sort of generic language. So you end up just falling back to the default in this. And then services. This is the basic organizational unit, things that I'll deal with when I'm actually doing deployments. When I do the configuration, I configure a service, you'll see this in a moment, through a serverless YAML file where I define the functions I want to run, the events that are going to trigger them, and any resources downstream that I need for that function to work with, right? And this works on, as I said before, on multiple cloud providers, okay? So let's look at how this works. We okay so far? All right, so in our GitHub repo, in the Keyhole, github.com, in the Keyhole, I have created so far 5 different examples. I promise I'm not going to go through all 5 of them, but I am going to go through a few of them today. But these are completely encapsulated dev container-based repos that you can download. You can clone these, go through the README. Each one of them has a README in it, but they're all, and I always do my VS Code dev container plug, so this is that for this month. Dev containers is beautiful. If you're not using dev containers in VS Code, you should be, okay? It's the idea of, you know, when you want to get a new project running on your machine, the traditional approach was, I go read the README and I go through the 27 steps it takes to get everything to the right version and level and configuration needed to run it on my machine. Whereas the dev container basically is an encapsulated Docker container that has everything configured you need to run it as soon as you download it, all right? All you need is VS Code and Docker installed on your machine. Everything else will come in for you. So these are all here. There's a Node TypeScript that deploys specifically to Azure, one that does the same thing but deploys to AWS. Then we'll jump into this multi-cloud example where we can talk about some of the options for making this a little more cloud agnostic. And then I want to look at something a little more sophisticated. This is a GraphQL API deployed using serverless. So we'll look at that as well, using our standard movie use case. So let's look first at this is Node.js TS Azure example. This is VS Code. I think most people are using VS Code now. but it's dev container based. When you download the dev container, there are some environment variables you need to set, and I created an environment template here that tells you what you need. So I'm going to deploy to Azure in this case. So you're going to need those Azure keys, right? You're going to need your subscription ID and your tenant and client, all the things that Azure needs to say you're legit and you can deploy on here and you're going to pay for it, right? I also have a README in here that kind of walks through this, how the dev container works, what you need for the dev container to work, what environment variables you need to set up, and then what you can do once you want to run this. These are node-based. Serverless by default runs in Node or NPM or Yarn. So I've configured a bunch of Yarn scripts to just kick these things off. Describes what they are here. And then because this is Azure, and Azure uses a soft delete mechanism, after you undeploy something, there's some undelete or there's some soft delete removal here so that you actually clean up the account if you happen to run this and deploy so you don't pay for it later. But the README should have everything in here you need to run. So this is the first couple examples are you know, the standard hello world, goodbye world scenarios, right? Really simple because we're just trying to demonstrate some concepts here. So this is TypeScript based. So in here I have a hello TS TypeScript file. And in here you'll see that pretty simple, that's all the code, right? I have a function called say hello. This right here is what is specifically tying me to Azure. And the reason this is still important, even in the serverless framework world, is as I pointed out earlier, the event handling is different across the cloud providers, right? So the way Azure handles events and the payload and what it looks like is different than the way AWS handles events and its payload. So you have to have specific code when you're deployed on that platform to say, I'm receiving an event from some Azure trigger, right? And it's going to look this certain way. So even though I'm somewhat cloud agnostic from a deployment standpoint, my code is still tied to Azure in this case, okay? We'll look at some strategies maybe to overcome that in the next deal, but real simple. It's an Azure function. It's expecting to get either a body parameter or a parameter off the command line in a GET request that gives a name, and it's going to say hello to that name. If I don't have the parameter, it's going to complain, right? Real simple function. Not exciting. And the goodbye is the same way. It just says goodbye. It looks exactly the same way. This is TypeScript, so let's just quickly walk through the files here. TypeScript config, because I'm TypeScript, so this is telling the TypeScript compiler or transpiler how to produce JavaScript and what I want it to look like. Standard TypeScript configuration. I am using Webpack here, and this is part of the, I'll call it the customization of how I want to optimize my code that I can add to serverless. So I can include Webpack. The next one we'll actually look at ES-Build, which is a Webpack, kind of a new approach to Webpacking. And what else is in here that's important? I included a Postman collection in every one of these repos. So actually, once you launch it, you have a Postman collection there. You can go execute it. And that's really all of interest in here, I think. The file then that we really care about is this serverless YAML file. This is the YAML that's used to actually tell the framework how to deploy this application. What functions I want to deploy, what events I want to set up, what triggers I'm going to handle, and so on. So in here, you'll see that I give the service a name. This can be anything. It could be Jamie. And then kind of the most important part here is the provider. I'm saying the provider for this application is going to be Azure. Okay, I'm going to deploy this serverless function as a service onto the Azure platform. I want it to go to some location defined by my environment variable that I showed you how to set up, right? In this case, it's going to US Central. What runtime am I going to use? What stage do I want to use? So in this, all the function as a service providers allow you to have stages, so you can have a dev, test, prod stage and discern or discriminate between those. And then because I'm Azure, it's going to define the resource group, right? So resource groups are a way to categorize deployments or group resources that go for a specific application or group of applications, right? So I'm just giving it the same name that I gave before. Again, this can be anything I want. You'll see how that when I deploy this, how it ties together. I'll come back to this in a second. Here's where I'm customizing my deployment, my optimization. I'm saying I want to use Webpack. And then kind of the meat of this is what functions am I going to deploy? Okay, I'm going to deploy a hello function, and the handler is this. Okay, so if we jump back over here, you'll see that source, handlers, this folder, hello, this file, didn't mean to click on that, and then say hello. Okay, if I look in my hello, my export is say hello. Okay, so that's how that's tying that together. It says this function is defined in this folder in this file, and it's exported as this name. Okay, so that's how that all ties together. So far, so good. So that defines my function. Then I say, what events do I want to respond to? In this case, I want to be an HTTP event because I want a REST-based endpoint. I want to respond to GET methods, and I don't want any. I can hit this anonymously. I don't need any auth at this point in this simple example. Goodbye looks much the same way. Okay, I'll come to plugins in a second. On top of that, then I can do this in Azure. I can do this API my API management, basically my API gateway. So I'm saying in front of my Azure function, I actually want to stand up a gateway as well, and I want it to be called V1. And here's some metadata about it. I want it to be HTTPS. I want to hit it through the V1 path. Don't require a subscription, and I'm using no auth. Right? There's probably, I don't know, 25 or 30 configuration variables I can use on API management. So it can get very sophisticated. This is kind of bare bones, right? But now I've got a function defined that has an HTTP endpoint with a trigger, listening for events, and I got an API gateway sitting in front of it that I can come through and do API gateway stuff, right? I can meter, denial of service attacks, all the things I can do through a traditional API gateway. And then down here, I'm saying I want to use these plugins. Because I want to use Webpack, Serverless gives me a Serverless Webpack plugin to say, okay, when I get ready to package this, because remember, Serverless is going to do two things. It's going to package and it's going to deploy. During the packaging phase, I want a Webpack. And then this Azure Serverless Azure Functions is really a local debugging mechanism so that I can actually run these lambdas in my local environment, these Azure functions in this local environment without spinning up all the infrastructure on AWS, which is kind of the coolest feature of the whole serverless framework, is I can run all of this on my local machine, run through it with never deploying anything to Azure, test it, debug it, and then deploy it. Okay? I don't have to connect a remote debugger. I don't have to go through any sort of cumbersome API to do, excuse me, to do that. It's just going to work because I'm including this this plugin. This is a simple example, but if I had dozens or hundreds of these things, managing this file now becomes a new challenge, right? How's the best way to do that? They're talking. I'm going to recap here in a second. So there's a sidebar going on here about the complexity of this versus using a native approach, on either Azure or AWS. And I agree. I'm in no way, and I should have put this disclaimer, I'm in no way saying this is the best solution ever. I'm just giving you, this is out there. I've used this on 2 accounts so far, and it's worked well. And I think the complexities that you see here, I think are still less complex than what I experienced trying to write straight templates and manage those. Whether or not that's just my inexperience with that templating language, that could be a reality as well, right? So, mileage may vary, I guess is the way to say this, right? All right, I'm going to move on here because I got limited time. So I want to run through a couple of just use cases. And again, take this as a learning experience. This is what's out there. This is what's offered. And this is part of our job, right? We got to look at these types of things and discern, is this a good approach for the problem space we're trying to tackle, right? May or may not be. But if I was to come here, let's look real quick at the package JSON. So in here, you'll see I have 3 scripts, and they're really all based off of the serverless CLI, okay? So earlier on the slide, when I said, what is Serverless Framework? It's a CLI that does these packaging and deployment functions for me, and they're based on this SLS or Serverless API. So if I come here and say SLS help, it's going to show me all of the options I have for running the Serverless API, including any plugins I've put in. So because I included the Serverless Azure plugin, I can do things like I can run this offline, okay? So if I was to come here and say SLS offline, you're going to see it's going to run my Azure function completely on my machine. It's going to build it. That's the packaging phase we talked about. And once it's built, it deploys it. I didn't deploy to Azure just now, right? There's no, if I go out and look at my Azure dashboard, there's nothing running on Azure. I'm running completely locally here. So I define my two endpoints. It stands up my functions on my machine. It also stands up any API management or any kind of dependent resources or triggering functions I have in front of that. So if I come out to my Postman here, and I go to my Azure example and I say I want to say hello to the local host, I've seen this on occasion. So one of the things, because I'm running in a dev container, I have to forward, because I'm my Postman and my browser are running on my local machine, right? My VS Code is running in a dev container. I've got to forward the port out of the dev container. Usually it happens immediately, but of course at the time you're demoing, it doesn't. And so it will come here in a minute. But see, this down here is showing me what ports are forwarded and nothing is there, so I can't hit it at this moment. Hopefully it's going to come momentarily and not ruin this whole thing. Interesting. I'm going to kill it and try it one more time. You got to be kidding me. It's not forwarding the port, so I can't hit it. I've only seen this once in like months of using it. Of course. All right, well, let's move on. What should happen here is it should forward that forward, and I could come out here to my Postman and hit it from my local machine. If I were running this all on my local machine, it would just work. Because I'm in a dev container and that's failing, that's not going to work for some reason. But the idea here is, and this is the point I want to make, is doing this kind of local debugging and testing in a traditional Azure function space can be difficult, right? Because I've got to deploy it to test it. How then do I connect a debugger to it, step through my code, right? I end up in that scenario where I got to put a bunch of console outs, right, and read log statements and try to figure out what's going on. For some reason, my ports aren't forwarding here, so that's not working. So, but you get the premise, right? Is I've stood that up. I'm running it locally, hopefully, because I want to show you some debugging, but hopefully that'll kick off here in a minute. But if I wanted to deploy this to Azure, I can come here and say SLS deploy. Real quick, let's go out here to Azure. So when I deploy to Azure, I'm typically going to deal with their resource management and specifically resource groups. And this is tied to my configuration. Remember, I gave it a resource group name. So I'm saying any infrastructure I provision, I want to be part of this group so I can manage all that thing as one unit. I can provision it, I can destroy it with just managing that one group. If you look here, I don't have the two SLS things. I have my movie API and I have my multi-cloud, but I don't have this simple hello world out here. If I come here and say SLS deploy, it's going to start to go through that packaging phase again, and then it's actually going to go through the creation of an ARM template. It's going to deploy that ARM template, creating that resource group, and then you'll see it start to stand up all of the resources on Azure for me. And this takes about 2 minutes. Let's wait here, and I'll just come here and we'll talk through this as it shows up. So there's my resource group that showed up, right? So there's my resource group that showed up. And in here, you'll see my resources. It's already stood up my API management interface and my app insights for monitoring. And as we refresh this, as it continues to build things out, now it's created my storage account. That's where the code's going to go, right? It's going to upload the code that I packaged up into a storage account, and then it took it away. And then it added it back. How come demos always go this way, where stuff takes longer than it should? Yeah. There it goes. So now here's my function app that it's standing up. If I go in to look at my function app, you'll see that it's going to give me a URL for that function app. That's what I can actually hit. And here momentarily, this should finish and we'll see that I can go hit it. ARM deployment's complete. It's deploying my serverless functions, uploading the file into the storage account, finished uploading the blob. I might be able to hit it now, not wait on the rest of it. So now if I go here to Hello Azure, so now I'm hitting my endpoint sitting out on my Azure function. So now I'm hitting my endpoint on Azure, and if I send it, it's not quite there yet. Deploying my API keys. There it goes. So there's Hello Jaime, right? Pretty exciting. Hello Keyhole. Oh, let me show you this real quick. So my first invocation here was 3.03 seconds. That's that cold boot latency, right? The first time I hit it. If I come back and hit it again, now you'll see I'm 57 milliseconds. So that's sort of demonstrating that cold boot time, right? There is no, on any of the providers, there is no set time limit of when it's going to reclaim those resources when it's not being used, right? It's arbitrary, somewhere usually between 5 and 15 minutes from what I've seen on graphs that I've looked at, okay? So meaning that if I were to sit here and wait long enough, it's going to take that resource away and I'm going to pay for that cold boot latency again at some point, right? If it's not being hit. But I'm also not paying for dedicated infrastructure during that time, which is the benefit, right? So while I agree that, and that's why I said that word where they said radically, remember the radically word they used? Whether this is radically easier, I think is debatable. I definitely, just from my experience of creating ARM templates, this is far less configuration than I would need to do it through an ARM template. And I don't necessarily always understand the ARM template syntax. I spend a lot of time digging through documentation to find when this is pretty straightforward, I think, in my opinion. I'm going to try to, and I can come here and now say SLS remove, and it's going to undo the whole process, right? It's basically going to tear down all of that infrastructure it created for that Azure resource. And it prompts me for a confirmation, and now I can remove it, okay? Let's jump over to a different example. So clone, GitHub, multi-cloud. So here's an AWS example. I'm not going to do all the same things I just did. I just want to give you an idea of the type of code you have to write to go from AWS or from Azure to AWS. So starting my dev container. This is the beauty of the dev container world, right? I don't have to worry about all my versions of Node, TypeScript. I don't have to install my CLI for Azure or AWS. All of it's just included here in my dev container. So if I look at this source, this is I intentionally made this a little more sophisticated, because I wouldn't write a lot of hello worlds, right? I'm going to need some sort of middleware, typically in my apps and things. So this does the same things. So if I look at my handler here, I basically have the same sort of say hello. I'm using MIDI for a middleware solution in here. But in essence, it's the same kind of code where I've got this REST endpoint that's going to say hello to me. But if I look at this, I'm using this API gateway that I created down here, and it's using AWS Lambda versus that Azure Functions library, right? So again, because of the difference in the way it handles events and triggers, I have to use a specific library, whether I'm using Node or Go or Java or whatever, right? I got to have a library that understands the format that these events are going to get passed over. But the same thing works here. And if I were to look at my serverless YAML, I made it TypeScript in this case, to your point, Dave, is rather than having YAML here, I can make this TypeScript or JavaScript, could be straight JavaScript, and I can import functions. I could import any of this configuration from another file and sort of start separating this file into more manageable chunks and having one giant file that just lists out everything, right? But this configuration is all the same. It's just formatted now in a TypeScript file, right? So my service, my plugins I want to use, this one's using ESBuild, which I found is far superior to Webpack in terms of its efficiency, really, really fast, and does a good job. In the AWS world, you use serverless offline instead of the serverless Azure functions to get that offline capability we talked about. But I can configure an API gateway, environment that my functions need, and then I can define my functions in much the same way that I did before, right? And I could come here. Let's actually see if this works. I can do a yarn start, which is going to run my SLS offline. See if it'll expose a port so I can show you how to debug. There it is. See how I exposed ports that time? So there's my ports sitting out there. So now I have a function here on dev hello. If I go back out to my Postman, I can go to my AWS example, and I can hit my hello function right here, all running locally. I did not deploy to AWS, right? I'm just running that same function here locally. If I want to debug in JavaScript debug terminal, and I can do the same thing, yarn start. I can go up to my source code. This is the single greatest time saver that I found in this world is I can come here and set a breakpoint. Notice that my breakpoint says it's unbound. which is really interesting to me. The first time I did this, I was like, why can't I get my little red dot there? Well, it's because that function's not loaded, right? As soon as I come out here, make sure my ports are there, they are. As soon as I come out here and hit it, there's my breakpoint. Now my breakpoint's red, right? So it loaded that function on demand, just like you would expect. And now I can do everything I can do in a normal debugger. There's my event, there's my body, there's my name, right? Really, really powerful in terms of testing and debugging serverless functions, I think. I could come here, I'm not going to do it for time's sake, but I could come here and do a yarn deploy. It would push that all out to AWS, stand up my API gateway. I could hit it just like I did on Azure, right? So the two things that you have to think about are my provider, where do I want it to go, right? I write the code, where do I want it to go? And then because it's provider event specific, I have to use libraries that are provider event specific, right? That's a downside. But if I were to jump out here now, let's go to the multi-cloud example. Same thing, it's a dev container starting up, so it's going to load all my things I need to run in this world. So in this case, I have the same kind of code, right? I have a hello and a goodbye. But I want this to be, this is sort of striving for that cloud agnostic thing that a lot of companies are talking about. How can I more easily move from one cloud provider to another, right? If I look at my hello TS file, I'm now using this library called multi-cloud. It's an app multi-cloud SLS core, and then I can include whatever other provider, whatever specific providers I want to deploy to. I want to go to Azure. I want to be able to go to Azure. I want to be able to go to AWS, right? If I want. This library will handle that multiplexing of the event handlers so that it knows, well, if I get an event from AWS, it looks this way and it'll pass that over to my function in the right format, right? So I've eliminated that specific Azure code. Now, some would argue, well, you've included them both now. True, but at least I have a system now that can go either way. If I was only Azure at the beginning, I could do this and run just fine. And then at some later point, if I switch to AWS, go to AWS, or if I want to use them both, I go to both, right? So this is an option here. In the configuration, however, I have, this is the way I separated, just because it made sense to me mentally, is I have an AWS deployment configuration and I have an Azure configuration, right? Because again, they're different. So if I look at AWS, it defines my functions and says, use the AWS provider. In Azure, I have the same functions, same exact code pointed to the same files, but my provider is Azure, right? If I were to go do an SLS deploy here, which we don't have time to do, it would go to both. I could hit them both, and it's running the exact same code, right? Which has some benefit. The rub there for me is still all of those dependent resources, right? Again, if I'm using DynamoDB on AWS and I'm running Cosmos on Azure, I'm stuck with those things, and my code's going to have to look that way, and I'm going to have to do something to manage my code to get it to flip, right? So could I run my function on AWS and hit an Azure Cosmos DB? Sure, I could. Why would I do that? I'm not sure, right? But I could. Could be done. Not sure it makes sense. One more thing. So Dave was saying there could at some point be abstract APIs or abstract frameworks that sort of abstract over the top of some of those things like Dynamo and Cosmos. I think the rub is Cosmos does a lot more than Dynamo does, right? It has a lot more features. So what do you do with those extra features? You know, they're not one-to-one like they do the exact same thing. They overlap. Is the juice worth the squeeze, right? Yeah. So last thing I want to show, and I apologize for running over here, is this is a much more sophisticated implementation. It's GraphQL based. So same idea though, where I have some source code. I have in here, I've separated this because I'm using the Apollo GraphQL framework, and they provide a AWS Azure function version of the Apollo, and they provide an a Lambda version of the Apollo. So I separated my code here into two different TypeScript files, okay? One for Azure, one for Lambda. All the rest of the code is the same, right? So if I look at my Azure functions, it uses Apollo Server Azure Functions library. If I look at Lambda, it uses the Apollo Server Lambda library. Everything else is the same. So my resolvers, my schema, my environment, everything is the same, and I can use the same code. I just separated sort of that top level setup. And then inside of my config, I simply point my handler to either the Lambda or the Azure version of the handler. My tree shaking and my web packing will take care of removing the code that's not used because it's not referenced in that case, right? But I can kind of achieve that, a little bit of that sort of cloud agnostic approach to this, right? The other thing of importance here, and you'll just have to look at this on your own, these functions are defined, they actually use a Postgres database. On the AWS side, I'm using RDS. On the Azure side, I'm using their Azure Postgres database. All of that configuration is in here. Okay, so if you look here at resources, this is my AWS side. This is pointing out to a YAML sitting here. That's sitting right here. Here's my Postgres CloudFormation template, right? This is where I was saying they haven't abstracted, and I'm not sure they can abstract everything, right? So my dependent resources are still cloud. This is CloudFormation language here, right? So it's a CloudFormation template that basically serverless frameworks going, oh, you want all these functions and events defined, but you also need all this supporting infrastructure. I can do that too, but I'm going to do it with just a regular CloudFormation template. If I look at Azure, here's the Azure template for the ARM template. See how complicated that is? That thing's horrific. That's the same thing for Azure to do the same exact thing, right? So it can be done. There is a, I'm going to call it a bug. Maybe it's just a feature. Whereas if you look at my Azure function, and this is, I cannot deploy this all in one shot for some reason. I don't know if it's something I'm doing. I haven't been able to figure it out. But if you actually pull this down and try to run it, the first time you deploy, it will deploy the database and the function will fail. Then you have to comment this out, run it again, it'll deploy the functions, and then you can uncomment, and every time you do subsequent deploys, it works. Feels like a bug, but I can't find anybody saying it should work. So that's what I had to do to make this work. But premise is still the same, is that I can manage my functions and all these dependent resources in some capacity, right? So if I was to come out here and look at my movie API, so here's an AWS version of Now Playing. If I hit this, you'll see that the first time it took 1183 milliseconds, and I'm just doing a GraphQL query. If I hit it again, now I'm down to 73 milliseconds, right? It's been booted, it's in memory, and this is GraphQL based, right? So I can come here and say, well, I don't want the poster path, and my poster path goes away down here, or I do want the poster path, and now I get the poster path down here, right? So complete GraphQL implementation in serverless. So Postgres, yeah, RDS on AWS, and the same code base, but I had to duplicate the configuration to do it. But yes, it can be done. Yeah, Dave was saying this may be a point where technically, as consultants, when we're looking at solving a problem, keeping our resources somewhat vendor neutral is an advantage. The disadvantage to that is Dynamo and Cosmos offer great features in terms of they're serverless. I'm not paying for them sitting there when they're doing nothing. They're extremely fast, way faster than a relational database, right? So there's technical benefits that you may want to go that way or need to go that way. But if you don't, then try to stay vendor neutral, I think is the lesson, right? So here's my RDS database that it deployed over here on the Azure side. I look at resource groups and filter this down to just SLS. Here's my movie API. Over here in my resource list, you'll see I have a Azure database for Postgres right here, right? Deployed them both through the same framework. Again, I had to duplicate the configuration to make it work, but it will work, right? I am somewhat vendor agnostic in terms of capability. I still have to plan for it though. So I guess at this point, let's wrap up. I would encourage anybody that's interested. These 5 repos are all public, all things you can go. If you go to In the Keyhole and just filter the repos down with SLS, you'll see them there. I have a Go example out there as well that is completely debuggable. This was a challenge to get debugging working in Go, but Brad Flood and I did that a couple weeks ago and got that working. He's using that on a client now.
Is it?
Yeah. Well, because it's serverless is the key, right? You got to be able to load that Go function locally with event handlers and a gateway sitting in front and get all that to line up in your local environment without deploying. Yeah, just deploying a Lambda Go function is super easy, but the debugging side locally is the trick. All of these have READMEs. All of these have Postman collections, so you should be able to use these. I'd also encourage anybody interested, let's go add more you know, if you're interested in this, do a Python, GCP, or, you know, do something different and just kind of get a feel for it if you have interest, or obviously if a client has a need, right? It would be nice for us to have examples of these things here. So thank you all.